Welcome to Kapadi Math Classes. This is the 15th video on single variable calculus. Based on problems in calculus of one variable by the author I.A. Maron. In this video, we are going to discuss about investigation of a function. Now basically, what is meant by investigation? Investigation means a systematic examination or a systematic research. Now we are going to do the systematic examination of a function or systematic research of a function. For these, we have some tools. There are, number one, some of them already we know them. Domain of a function, range of a function, zeros of a function, monotonicity of a function, limit of a function at a particular point, continuity of a function at a particular point, differentiability, integration, finding asymptotes of function. Now in this present video, I'm going to concentrate on monotonicity of a function because already we know what is meant by domain, how to find the domain, what is meant by range, and how to find the range. Lesson is monotonic function. A function is said to be monotonic function if it is either increasing function or decreasing function. So the two types are there. One is increasing function. And number two, decreasing function. If a function is either increasing function or decreasing function, then that function is called monotonic function. Now, let me discuss about what is meant by increasing function first. Now, what is meant by increasing function? And one, let's have a graph of function like this. Let y is equal to f of x is any function. Let's see the graph of the function like this. And this is the curve of the function y is equal to f of x. Of course, its axis y-axis. I'll take 2 points x1 and x2 here, and these are the f of x1 and f of x2. If you observe carefully, my x2 is more than x1. Correspondingly, my f of x2 is also more than f of x1. Then such type of functions are called increasing functions or strictly increasing functions. So first one. In the second increasing function, we have one more category. It's called strictly increasing function. Strictly increasing function. What is that? For all x1 comma x2 belongs to a domain of the function, whenever x2 is more than x1, this implies my f of x2 is also more than f of x1. Then we say that this function is called increasing function. Then f is called strictly increasing function. Strictly increasing function. Whenever x2 is more than x1, then f of x2 must be more than f of x1. Then f is called strictly increasing function, and graph of the function looks like this one. Let us discuss about one example about increasing function. Let's say I have a function, let y is equal to f of x is equal to x square, where x belongs to 1 to infinity. And the graph of the function like this. This is 0, x-axis, y-axis. The function is this. And here my domain of the function starts from 1 to infinity. So my graph starts at here. So this is the graph of the function. Between 1 to infinity. Now, if you observe carefully, the graph is increasing from 1 to infinity. How you can say, look here, let x1 and x2 belongs to 1 to infinity. What is my f of x1? And x2 is more than x1. Now, f of x2 is equal to f of x2 is equal to x2 square, f of x1 is equal to x1 square. Now here, x1 and x2 both are positive numbers. Please observe this one. x1 and x2 both are positive numbers. Now consider f of x2 minus f of x1, which is equal to x2 square minus x1 square, which is same as my x2 minus x1 times of x2 plus x1. Since x1 and x2 both are positive numbers, x1 plus x2 is positive. And moreover, since x2 is more than x1, then x2 minus x1 is also positive. Therefore, it is greater than 0. Therefore, f of x2 is more than f of x1. Therefore, f is increasing function. Now, let us discuss about it is strictly increasing function. Let us discuss about only increasing function. How the graph of the function looks like. Let us have another example. Y is equal to my function f of x. It is defined as, say for example, x, when x belongs to 0 less than or equal to x less than or equal to 2, and 3, for example, 2, and 2 when x is more than 2. Let me draw the graph of this function. F of x is equal to x between 0 to 2. Between 0 to 2, f of x equal to x, of course, identity function, the graph looks like this. And when x is more than 2, the graph goes like this. This is 2 units. Now, if you observe carefully, if I take my x1 here and my x2 here, now f of x1 is equal to f of x2. That means this function up to 2, the function is increasing function, after that it becomes constant function. So it is not completely increasing function. So this type of functions are called just increasing function. Whereas the earlier one is called strictly increasing function. What is the definition of this one? So increasing function means for all x1 comma x2 belongs to domain of the function, x2 is more than x1, then my f of x2 can be greater than or equal to f of x1. In the earlier example, the increasing function, there is no equality symbol here. Here you have equality symbol. F of x2 greater than or equal to f of x1. Then f is called increasing function. This is now. So in this monotonic concept, the second one is decreasing function. Decreasing function. Here also you have two types of decreasing functions. One is strictly a decreasing function and next one is just decreasing function. So here, number one, strictly decreasing function. Basic definition. That y is equal to f of x is any function let x1 and x2 belong to the domain of the function. As usual, my x2 is more than x1. Then my f of x2 is less than f of x1. Here the x values are increasing more, whereas my outputs will be in decreasing mode. So how the graph looks like? It looks like graph like this. So it decreases 0 x-axis. Let this is x2 and this is x1. My x2 is more than x1, but my f of x2 is less than f of x1 strictly. Then this function is called a decreasing function. Then f is called decreasing function. Of course, strictly decreasing. What is meant by strictly? Now, what is just a decreasing function? Here we have f of x2 less than or equal to f of x1. For all x1 comma x2 belongs to domain, x2 is more than x1, but my f of x2 must be less than or equal to f of x1. Then such functions are called decreasing function. Then f is called decreasing function. how the graph looks like. As usual, up to a certain stage, it decreases. Then after a certain stage, it becomes a constant function. So these type of functions are called x2. Such type of functions are called just decreasing functions. Okay, now every function need not be a monotonic function, right? Every function need not be monotonic function. That means we can have function neither decreasing nor increasing functions. I can repeat, every function need not be a monotonic function. That means a function can be neither increasing function nor decreasing function. Such type of functions are called oscillating functions. We have so many examples for this oscillating function in physics. Let us do one example for increasing, decreasing function. The question goes like this. Find the intervals of increasing and decreasing of the function y is equal to f of x is equal to x square plus bx plus c. Very highly useful example for the next level. So we are going to find in which interval my f of x equal to x square plus bx plus c is going to be increasing function and decreasing function. Solution. First of all, if y is equal to f of x is equal to x square bx plus c. First, let us assume that a is more than 0. Now I am going to convert this function into perfect square concept, perfect square mode. That is ax square plus bx plus c. You know from the elementary algebra how to convert this into perfect square. X plus b by 2a whole square plus 4ac minus b square by 4a. So my function is this. Now let my x plus b is more than minus b by 2a, and this is x2 and this is x1. My x2 is more than x1. My x2 is x and my x1 is minus b by 2a. Now find f of x. F of x is nothing but a times of x plus b by 2a whole square plus 4ac minus b square by 4a. And my f of minus b by 2a. When you substitute minus b by 2a, it will become 0. So we have only this part, 4ac minus b square by 4. Now I'll go for f of x2 minus f of x1. F of x minus f of minus b by 2a. If you subtract this from this, you have only a times of x plus b by 2a whole square. It's positive. Why this quantity is positive? Because we assume that a is positive and this is a square of a real number. Square of a real number is always positive. Therefore, positive into positive is positive, so greater than 0. Strictly greater than 0. That means whenever my x is more than minus b by 2a, then f of x is more than f of minus b by 2a. It is satisfying the basic rule of increasing function. That means when x is more than minus b by 2a, the function is increasing function. Therefore, for all x more than minus b by 2a, f of x is increasing. Okay, so conclusion is that for all x belongs to minus b by 2a to infinity, f is increasing. Case 2, a is less than 0 case. Case 2, y is equal to f of x is ax square plus bx plus c, a is negative. So here we have ax square plus bx plus c is equal to a times of x plus b by 2a whole square plus 4ac minus b square by 4a. So here the graph will be like this. And in the point, my x is equal to minus b by 2a. When x is more than minus b by 2a, the graph will be like this. That means decreasing function. When x is less than minus b by 2a, the function is increasing function. And this is the maximum value. So here, what is the conclusion? So number one, for all x belongs to minus b by 2a to infinity. For all minus b by 2a to infinity, f of x is decreasing. And D, for all x belongs to negative infinity to minus b by 2a, my f of x is increasing. Now the function is increasing and decreasing. Up to minus b by 2a, it's increasing mode. After minus b by 2a, it is decreasing mode. Therefore, at x is equal to minus b by 2a, function attains maximum value. C. At x is equal to minus b by 2a, f of x attains maximum. And what is the maximum value? And the maximum value is f of minus b by 2a, which is nothing but 4ac minus b square by 4a. And if you observe carefully, the function doesn't have minimum value, only maximum value. Last D, conclusion, y is equal to f of x is equal to ax square plus bx plus c, a less than 0, have no minimum value. So here, minimum value or maximum value, the deciding factor is a. When a is more than 0, function have minimum, and the minimum value is 4ac minus b square by 4a. When a is more than 0, the function have minimum value, maximum value, and the maximum value is again 4ac minus b square by 4a. That means the x is equal to minus b by 2a is a turning point. The curve is taking the U-turn at x is equal to minus b by 2a. This is about f of x equal to ax square plus bx plus c increasing and decreasing.